All right, so here is the discussion over the test for section 4.1 to 4.5 from pre-calculus for the test that was taken over the 2-day period. All right, so question 1, multiple choice. So to evaluate, we have a product of logs here. All the bases are different. So the easiest way to do this is to put them all in terms of the natural log base, or base E, using the change of base formula. So that's the natural log of 5 over the natural log of 7, times the natural log of 7 over the natural log of 3, times the natural log of 2 over the natural log of 5, times the natural log of 3 over the natural log of 2. And now, since they're multiplied in all the same base, you can look to divide out any factors from high to low, like natural log of 7s. You got a natural log of 2 dividing out, natural log of 5 divides out, and the natural log of 3 divides out. Now, when everything divides out, you're left with 1. And that is the answer. It's 1. So tomorrow, if you retest, you'll have to show that work. You can't just put 1 to get credit, but that's not that difficult. Cool. Example 2. This one on the original test was supposed to be a plus sign there. That is the answer B. Tomorrow on the retest, you'll have to do the work yourself. So here is how you do it. You take the natural log of both sides. The natural log of 3 times 2 to the x minus 1, and then the natural log of the right side, 4 times 3 to the 2x plus 3 power. Now you got to expand it. So every factor gets a natural log, exponents out front. So we get the natural log of 3 plus the quantity x minus 1, natural log of 2. There's the left side. The right side, the natural log of 4 plus, bring the exponent out front in a quantity times the natural log of 3. All right, now we need to get our x's together. So we have to distribute the logs into those products. So we get the natural log of 3 plus x times the natural log of 2 minus 1 times the natural log of 2. And on the right side, we get 2x natural log of 3 plus 3 natural log of 3. All right, so now we're going to collect our like terms, and we're going to get the x's on the left. So there's a term with an x, there's a term with the x. Bring them across. The x ln of 2 is already there. The other one becomes a minus when you bring it across, equals, and then everything that's not highlighted is going to go on the right side. So the natural log of 4 is already there. The 3 natural log of 3 is already there. And so we bring other things across. We get plus natural log of 2 and minus natural log of 3. The signs change when you bring them across. So now we factor out the x over here, and you get the natural log of 2 minus 2 natural log of 3. And over here, you can combine like terms. So we have the natural log of 4 plus the natural log of 2. And if you notice, 3 natural log of 3 minus 1 natural log of 3, that's just 2 natural log of 3s. And so the last step, I'll come over here to a new column, is to divide through by what you're multiplying x by. And you end up with x equals the natural log of 4 plus the natural log of 2 plus 2 natural log of 3 all over that factor in front of x, which is natural log of 2 minus 2 natural log of 3. And if you notice, that is not an answer choice. So now we start condensing. So I'm going to bring this 2 up on that 3. I'm going to bring the 2 up on that 3. And then I'm going to condense those. That becomes x equals the natural log of 4 times 2 plus the natural log of 3 squared. There's the numerator now. Natural log of 2 in the bottom minus the natural log of 3 squared. And then if you simplify that, you get x equals the natural log of 8 plus, let me do that 8 again, I don't like it. There we go, the natural log of 8 plus the natural log of 3 squared, which is 9, all over the natural log of 2 minus the natural log of 3 squared, which is still 9. And that does come out to be answer choice B. So there's the work for it. And tomorrow on the retest, if you get as far as this, if you just solve for x, you wouldn't need to simplify it anymore. We'll be happy if you could get to that point right there. Number 3, you're trying to solve for x. You got 2 log terms on the left and 1 log term on the right. So you're going to condense. They're both base 3, so you pull 1 log base 3 out. And since both terms are positive, their arguments get multiplied. So it's x times x plus 3, and that condenses the left. You can leave this on the right-hand side. And now because you got log equals log, you can either drop the logs, that's the property, or you can exponentiate base 3. But either way, you end up with x times x plus 3 equaling 28. And now you're solving this quadratic. So if you expand it, you get x squared plus 3x, and then you bring the 28 across, it becomes minus, and now it's equal to 0. That's a quadratic. You try to factor it as 2 binomials, so that's going to be an x and an x, and then we're going to have a 7 and a 4 with a positive and a negative. That'll get you a negative 28 product and a plus 3x sum. So now we get two solutions, x equals -7 or x equals 4. But remember, you got to try them out. Which one works? Well, if you plug a -7 in up here, you're going to get -7 plus 3, which is -4. You can't take logs of negative numbers, so you throw out numbers that give you negatives in the arguments. If you plug in the 4, you get a 7, then you get a 4, so 4 is the answer. The answer is 4, which in this case was B. But again, tomorrow on the retest, you'll just leave it like that. Cross out the x equals -7, box the x equals 4, and you're done. All right, number 4, you got 8 to the something equals 64 and 4 to the something equals 16. You're trying to find 2 to the xy. So we need to know x and y. So this is real easy to get the bases the same, and it's very similar to one that was in your worksheet. 64 is 8 squared. So now if you either log base 8 both sides, or because they're 1 to 1, you can equate the exponents. You get x plus y equals 2. Doing the same thing over here, we get 4 to the x minus y, and if you write 16 as the power of 4, you get 4 squared. So now you can equate the exponents, so x minus y equals 2. So if you bring that over here, because now you have a system of equations, I'll bring that over there. All you got to do to solve this system, real easy, is just add vertically, because your y's are already opposite signs. So you get x plus x, that's 2x, y minus y is 0, 2 plus 2 is 4. So now all you got to do to solve for x is divide by 2, half of 4 is 2. So x is 2. And then to find y, all you got to do is plug it back into either one of those. I'll plug it into the top one. So 2 plus y has to equal 2, which if you subtract 2, you get y equals 0. So now we know x and y, we can plug it in. So 2 to the xy power is equal to 2 to the 2 times 0 power. Well, that's the same as 2 to the 0 power, and 2 to the 0 power is 1. And there is your answer. It was E on the test. Tomorrow you'll just stop after you show all that work. I know I'm going fast, but you can hit pause. You can replay as many times as you need to get it. All right, here we have an English sentence, and we need to make a math sentence out of it. 1/25 of 505 to the 20th power is 125 to the x. So that's going to become 1/25. The word of means multiply in math. 1/25 of 5 to the 20th is the equal sign in math. So that's 125 to the x. And now you get all the bases the same. It looks like you can write everything as a power of 5. So 1 over 25 is 5 to the -2nd. And of course, this is already a power of 5. 125 is 5 cubed. So you write it as 5 cubed to the x power. Now over here, since the bases are the same, you add exponents. 20 minus 2 is 18. Over here, you're exponentiating, so you multiply, you get 5 to the 3x. And then now, again, because you have the bases the same, you can equate their exponents. So 18 equals 3x. Divide both sides by 3, and you get 18/3, also known as 6. Piece of cake, nothing to it. Practice, practice, practice. It was D on the test. Tomorrow, this is what you're showing. Number 5, domain. We have a log function, the domain. It's going to be affected by the argument. So all we got to do is set the argument, 5x minus 2x squared plus 3. We have to say it's strictly greater than 0. Okay, we can't take logs of 0 or negatives. Now this is a quadratic, so if you write it in descending order, -2x squared plus 5x plus 3, now your goal is to factor it. We know it's a parabola that opens down. So to factor it, we'll factor out the negative. It's a lot easier to factor something when the leading term is positive. So there you go. So now we'll factor it still with the inequality intact. It's going to be a 2x and an x, and 3 is prime, so it's got to be a 3 and a 1. And because we want a -5, we need a -3 there and a +1. Okay, so this is still okay, but you can't set each factor greater than 0. That's where the problem breaks down. But what you could do is find the x-intercepts of the parabola by setting each factor equal to 0. You get x equals -1/2 and x equals 3. So that's enough to generate a graph. So here is -1/2 and here's 3. Those are the x-intercepts of the parabola. We know the parabola opens down, so it looks like that. And now we want to know for what values of x is the graph of that greater than 0. Greater than 0 means above the x-axis. So notice that's going to be everything between the x-intercepts. So everything between the x-intercepts, this is the and case. So your answer in interval notation is -1/2 with a parenthesis to 3, and you could put an x epsilon there. In inequality notation, that would be -1/2 is strictly less than x, which is strictly less than 3. So because it opens down, it's positive between the x-intercepts. Had this thing open up, it would be everything outside the x-intercepts. And so now you look for that answer, -1/2 to 3. and it's B. So tomorrow, again, you won't have the answer choices. You'll just list it in either one of those, inequality or interval notation. All right, what is the constant percentage decay rate? So this is a decay function. The base is 0.24, so that's the decay factor. But remember, the decay rate is by what percentage do we lose each period. So 0.24 being the decay factor, if you multiply by 100, you get 24%. So according to this, we only retain 24% each cycle. So the decay percentage rate is how much we lose. So all you got to do then is subtract 24% from 100%, and you get 76%. So if we lose 76% each cycle, we'll retain 24%, and that's why the base is 0.24. Because this equation tells you what amount you have at any given moment. So again, if you only have 24% of what you had previously, that means you have lost 76%. And that's what we call the decay rate, or the decay percentage rate. It's A in this case, but tomorrow you start at 76, so you will have to show that you're converting the decimal to a percentage, and then you have to show that you're subtracting that difference from 100%. All right, the next one here, number 8. Which of the following is the inverse of this? All right, so g of x is a fancy name for y. The money step is when we interchange x and y. So g of x becomes x. We have 3 log base 4 of x becomes y. So there's interchanging your variables. And now it's just a matter of solving for y. So we subtract 1 first, and that gives us 3 log base 4 of y minus 2. Now we divide through by 3, or multiply everything by a third. So you have a third of x minus 1. It divides out on the right, and you're left with log base 4 of y minus 2. So that got our log isolated. Now we need to unlog it, and since it's base 4, we'll go ahead and exponentiate both sides base 4. That's how it looks. So we're left with 4 to the 1/3, x minus first power, and then 4 to the log base 4 of y minus 2 is just y minus 2. And now all we got to do to solve for y is add 2 to both sides. So we're going to have 4 to the 1/3, x minus first power, and then plus 2 on the ground floor. And then all you got to do, since you now resolve for y, is give it that special name. It's the inverse of g, so we'll call this g inverse of x. And it's really the same thing, 4 to the 1/3, x minus first power, and then plus 2. So if you look for that answer, matched up on the test, it's answer choice A. Of course, tomorrow you won't have answer choices, so you will just stop right there. Right there. Perfect. All right, number 9. Natural log of 3 is u, natural log of 5 is v. Then we need to write natural log of 45 in terms of u and v. We means the same thing as writing in terms of natural log of 3 and natural log of 5. So we look to factor 45, and I know it's 9 times 5. And now I can write 9 as 3 squared. So there's the prime factorization. And that gets it in terms of 3 and 5, which is what we wanted over here. So now we just expand it using the properties of logs. So that becomes the natural log of 3 squared plus the natural log of 5. And before we can replace the natural log of 3, you got to bring the 2 out front. So it becomes 2 times the natural log of 3 plus the natural log of 5. And now I can replace the natural log of 3 with u. So it becomes 2u plus the natural log of 5, which is v. So the answer is 2u plus v, which on the test was answer choice C. Tomorrow you leave it as 2u plus v. And the last multiple choice, solving for x. Okay, so we have a log of a log of a log, and notice the variable we're trying to find, x, is on the very inside. It's the base of our resultant log. So all you have to do to this is start peeling back the layers to get to the x, working from the outside in. So the first thing you notice is you have a log base 10 out there. So to unlog base 10, you exponentiate both sides base 10. So that's what it looks like. So now 10 to the log base 10 of blob is the blob. And that blob is log base 2 of log base x of 25. And on the right, 10 to the 0 power is 1. So that removed one layer. Now we have the outside on the left being log base 2. We need to undo that, so we'll exponentiate both sides base 2. So now on the left, 2 to the log base 2 of blob is just log base x of 25, the blob. And on the right, 2 to the first is 2. And we've been having so much fun doing this. Now we need to unlog it base x. So I will exponentiate both sides base x. And x to the log base x of 25 is, of course, just 25. And we get x squared. And now it's a quadratic. So when you solve by taking the square root, You get -5 or +5. But remember, our original x was a base. And we know that our bases have to be between 0 and 1 or greater than 1. They can't be 0, they can't be 1, and they can't be negative. So the only answer that works is 5. So again, you're going to show on your test tomorrow when you retest. I'll put a blank there, there wasn't one there. You're going to have to show me that you're considering both values of x, and then you're making your final decision by xing one out and boxing the other one. So there's the multiple choice. Watch it over and over and over again, and then hit pause, and then try it again over and over again until you can get it right. Okay, that's how you practice. All right, so here was the free response. This one was with the calculator. This was a logistic equation. We had the Grinch there spying in on Wasselfest that just took place, the snow Wasselfest. And the equation says the number of people at Wasselfest infected with the holiday cheer after T minutes is modeled by the function W of T equals, and there's the equation. So first thing you got to do here is get it into your Y equals correctly. And there it is. Remember to use the horizontal division bar. The way you get that is alpha Y equals, and it's number 1, it's N over D. Okay, so you double check, triple check, make sure you get it in there correctly to get e to the power of its second ln. Now, if you hit zoom 6, you're not going to get a meaningful graph. So remember, what are we measuring? Well, on the x-axis, we're measuring time in minutes. So if you go to your window, I always like to put -1 for the x-min so we can see the y-axis. Now, this is kind of what you're guessing. How many minutes do you want to go by at Wasselfest? If you give it 2 hours, let's try 2 hours. That's going to be 120 minutes. We might come back and modify that. Turn your x scale to 0 so you don't even have a tick mark. Your y-min, put that at -1 like we always do. We're mainly interested in the first quadrant. Putting y-min as -1, you see the x-axis. Now, y-max is not something you guess at. Remember, the numerator is your upper limit to growth. That's 13,659. So you need to type a y-max that's a little bit bigger than that. So I'll go with 14,000. So back to my window, my y-max, that's 14,000, 14000. And for sure, turn your y scale to 0 so you don't get 14,001 tick marks on your graph. Now, if you hit graph, you should see an S-curve. Notice mine is an S-curve, but it accelerates very rapidly and tapers off. So 2 hours was way too long. People were getting infected with the holiday cheer much faster than that. So I'm going to trim a little bit off my X-max. Instead of 120 minutes, let's try 20 minutes. Doesn't take long to get in the holiday spirit, especially when it's snowing at Wasselfest. So that's a much better looking S-curve. So now we see the S-curve, we know we can answer questions and get the right answer. So here we go. What was the initial number of Wasslers infected with cheer? Round to the nearest person. So initial corresponds to a t value of 0. Since the function's name is w and we're plugging in a 0 for t, you must show w of 0. And now it's just a matter of going to your calculator, typing trace. It's going to show you your cursor. It's going to give you ugly values at the bottom. But believe it or not, it's waiting for you to type something in. So if you type 0, hit enter, there it is, 249. We don't even have to round that number. It's a nice whole number. So this is 249, and the units are Wasslers, people that are at Wasselfest. So we'll call them Wasslers. That was a check on the test right there, with the notation, with the number, and with units. Part B, after how many minutes will the infected number of Wasslers be 5,000? So now they're giving us the Wassel number, so W of T equals 5,000. That was a check. That's your setup. Whenever you're using a calculator, got to show us what you're doing to solve. So underneath there now, when we solve for T, we'll put T equals. So now we go to Y2, and we'll type in 5,000, hit graph, and we're looking for the point of intersection. So that second trace, that's your calculate menu. We want number 5. You can just hit enter for your first curve, enter for your second curve, and you get to enter for your guess. It'll find it for you. There it is. It's 4.29. So for rounding to the nearest minute, we'll just report 4 minutes. Okay, 4 minutes. Now, if you wanted to, you could put 4.29 to 3 decimals. Let's see, it was 294. You can truncate or round 294, and then you could say which is approximately 4 minutes. Make sure you put units of minutes on your final answer, or you can just do this. You can just say equals 4 minutes. That's fine. So that was a check when you had T equals 4 with units. That was the other check. So that's 3 checks so far. We'll tally them up here. That was the first check up there. This was the second. This was the third. All right, now it says to find the simplified exact answer to the question that we just answered algebraically. So here's what I'm going to do. I'm going to copy it up here, not W of t, but the expression that's equal to W of t, because I need to work with this in order to solve algebraically. So I'll copy it up here, 0.8t. I'll extend that out, and then I will cut that out and come down here on the far left, and I'll paste it. All right, so now I want that to equal, just like above, 5,000. 5,000. So we did this in class a couple times. The first thing you're going to do is multiply both sides by the denominator. So put that in parentheses. I'm not going to show it, but when you multiply on the left, it divides out, and it gives you 13,659. And on the right, you get 5,000 times that quantity, which if it's not in parentheses at this point, you've already lost a check. It's a two-term quantity. Now, instead of distributing the 5,000, I'll just go ahead and divide through by the 5,000. So we're left with 13,659 divided by 5,000, and that equals 1 plus 54 e to the negative 0.8t. Now, if you want to try and simplify that fraction, type it into your calculator and hit Math Enter Enter. It's going to give you the same fraction. It doesn't simplify. All right, so now we're going to try and isolate the variable term, which is that. So we subtract 1. So we get 13,659 all over 5,000 minus 1. And that equals 54 e to the negative 0.8t. So now here's where you can actually use your calculator. I'm going to type this piece in to the calculator and let it tell me what it is. So we'll go to the home screen, and we got 13659 divided by 5,000. You don't need to use the horizontal division bar here. That's 2.7318 and then minus 1. So that actually is a terminating decimal. So that is 1.7318, and that equals 54. You know what? That's kind of bad. I don't want to do that. That's a decimal. It may not terminate. So what I'll do instead is this. This is the better thing to do. So pardon that leaning on the calculator too much. I'm just going to call 1 5,000 over 5,000. Okay, and now we'll have a 5,000 in the denominator, and now you can go to your home screen and do 13,659 minus the 5,000, or you could do it in your head, and that gives you 8,659. So that one we know for sure is correct, and that equals 54 e to the negative 0.8t. Now, instead of dividing both sides by the way, there it is. There we go. We're back. Now, instead of dividing both sides by 54, that's going to give you a complex fraction. I'm going to go ahead and multiply both sides by the reciprocal of 54, which is 1 over 54 over here and 1 over 54 over there. So now I'm going to come up to this next column. I'm going to multiply straight across on the left. So I still have 8,659, and then 54 times 5,000. That's what calculators are for. 54 times 5 grand. And that gives you 270,000. 270,000. So make sure you count your zeros. There should be 4 of them. And that equals over here the 54 and the 1/54th divide out. So that's just equal to e to the negative 0.08th power. Now we'll take the natural log of both sides. So we get the natural log of 8,659 all over 270,000. And then that equals just negative 0.8t. Well, negative 0.8t, that's a decimal. We have a fraction. So the way you actually read that is negative 8/10. So I'm going to write it like that instead of 0.8, negative 8/10 t. Well, now if you want, you could simplify. I'm just going to copy that, paste it, go to a separate line. We can simplify 8/10. 8/10 is the same as 4/5. So now all we got to do to solve for t is to multiply both sides by the reciprocal of negative 4/5, which is negative 5/4. I'll do it over there, and I'll sneak it in over here. And we're almost done. It divides out on the right, and you're left with t equals negative 5 over 4 times the natural log of 8,659 over 270,000. And that was the preferred answer, because you know that's exact. Anytime you're dealing with decimals, you can't be quite sure if the calculator is chopping some off or if it does terminate and it's still exact. But because it did ask for the exact answer, we know this is exact. Rational numbers is fractions. Okay, now I got to put units on there before I forget. That would be minutes. And since we have the time, let's just go ahead and type that in. It should equal the value that we found up above, which we've already rounded to 4. So let's see what we get. Negative 5 divided by 4 times the natural log of 8659. 8659 divided by 270,000. That should give you that 4.299 number. Yeah. So there it is. So we know it's correct. So that's what the nice thing is about having a calculator for this. We can check to make sure it's right. All right. So now back to the calculator exclusively. That was the one little algebra thing from the 4.5 section. After how many minutes is holiday cheer spreading at the fastest rate? Well, of course, we know that for logistics, they look like this. There's that upper limit to growth, dotted line actually, and it looks something like this. We know it's always going to be, this is your y, x-axis, y equals 0. It's always going to be at the halfway point. That's when the graph is the steepest. So we need to figure out what half of 13,659 is. So I'm going to come over here first and do 13,659. I'm going to divide it by 2. And that's a job for the home screen, right? 13,659 divided by 2. And that is 6829.5. So I know we can't have a half of a Wassler, but to be as accurate as possible, we're going to keep it as that. So now, since that's Wassel units, we're going to put W of T equals 6829.5. And that is another check. You can't see what I'm doing. There it is. W of T equals 6829.5. You don't need to put units there because that's not your final answer. I'm going to get ready for the answer, which is T equals. Now I just go back to the calculator, and in Y2, instead of 5,000, I put 6829.5, hit graph, and I look for the point of intersection. This one should be visually at the midpoint vertically, and it is. So now back to the second trace, number 5. Enter, enter, enter. Come on in. It's 4.9. So if you're going to round and not show any decimals, 4.9, I would definitely round here instead of truncate because it is so close to 5. So I'm just going to put down 5 minutes. And you don't have to put approximately here. The only time you have to put approximately is when you're equating two numbers. Like if I would have put, again, T equals 4.979, then I would put the squiggles 5. But in this case, you're good. So that was another check with the T, the 5 with the minutes attached. How many Wasslers are infected after 15 minutes? Well, that's now a time value. So that's W of 15, like we did on Part A. You got to show W of 15. And now, if you want to go back to Y equals and get rid of that, so you only have your logistic graph again, hit trace, 15, enter. And now it says to round to the nearest person. So I'll just put 13690. And since it's 0.4, you drop them. There's not the option of rounding up there. So you just write down that number, and you put Wasslers again. Wasslers. And that was one check. Again, with the W15, with the answer, and with the Wasslers intact. One check. According to the model, how many people attended Wasselfest? Well, what we're really after here is what happens as time approaches infinity, assuming Wasselfest is still going on. Well, that's real easy. That's just the upper limit to growth, which we've been talking about this whole time. That's 13,659. So 13,659 Wasslers. And you don't even have to have the limit there in front. It's nice to have it there, but this was the one where you could just put the answer with Wasslers and you get the check. We're kind of expecting you to know that. All right, so here's the shutdown plan. If the Grinch has a plan to shut down Wasselfest, if 75% of the total people that arrived at Wasselfest get infected, after how many minutes will he try to implement his sinister plan? So we want to take 75 of 13,659. So that's 0.75 of 13,659. We need to know what that number is. So I'm doing that off to the side on my math workbench, and I'll go back to the home screen. So 0.75 times 13659. Boom. And we get 10244.25. We can't have a quarter of a Wassler, but we're still going to use that number to be as accurate as possible. So now this is the third time I'm giving you the Wassel value. W of T equals that number, 10244.25. There's your setup. And now, same thing. Go back to Y equals and graph that over here, 10244.25. Graph it. Find the point of intersection. Second trace, number 5. Enter, enter, enter. And it does say to round to the nearest minute, so underneath there we'll put t equals 6 minutes at 6.3. So underneath there at 6 minutes. And that was the last check. You needed all of this to get that last check. All right, so there, that should have been 10 checks. Tomorrow, you got your calculator again. If it's not the exact same numbers, it'll be something very, very, very similar. The questions will be answered in pretty much the exact same way. Make sure you include units. Make sure you include all of your setups, and then you answer the questions correctly. Practice the notation. This is pre-AP. You're expected to speak the language of mathematics. All right, that's it. Watch the video 10, 20, 100 more times if you need to. Whatever you need to do to get 100 on your retest tomorrow, because you know what the questions will be. We'll see you there.